For our next example, we are asked to add two rational expressions that have different denominators. Now, if this is the case, in order to add them together, I have to find a least common denominator. Well, least common denominator would be the least common multiple of the two denominators. Thinking back to when we were just working with regular fractions, this would be as if I took 1/2 plus 1/3. In this case, 2 and 3 are not common denominators. The least common denominator of, least common multiple of 2 and 3 would obviously be 6, which is the product of 2 times 3. Well, I need to turn each of these fractions into a fraction with a denominator of 6. That being the case, I have to multiply the fraction on the left by 3 over 3 because my denominator needs to be 6, and at the moment I only have a 2 here. So 2 times 3 makes 6, which gives me 3/6 for that fraction. The fraction on the right, I need to multiply by 2 over 2, 2 being the missing factor of the product 6 that I desire over here. So this turns into 2/6. Now that I have the same denominator, I add 3 plus 2 to get 5 over a common denominator of 6. Using that same idea, we're going to add the two rational expressions here. Now, I have x plus 3 for a denominator and x minus 5 for a denominator. Those are both binomials that are as fully factored as they can be. That being said, the least common multiple of these two factors would be the product x plus 3 times x minus 5. Just multiplying the two of them together. I won't FOIL this, I'll leave this in the factored form in case I can simplify in the end. Now, with that taken care of, I have to somehow change each of these fractions so that they have that common denominator. Well, the fraction on the left already has x plus 3 as a factor. It's missing the factor x minus 5. That being the case, we're going to multiply both the numerator and the denominator by that missing factor x minus 5. Now notice this turns our denominator into x minus 5 times x plus 3, which is the same as we see over there. In the numerator, I will then use FOIL to multiply these two binomial expressions together. I'll save that for just a second. The fraction on the right already had x minus 5 as a factor. It's missing the factor x plus 3. I need to then multiply the numerator and denominator by that factor x plus 3. My denominator, I have the two factors that I need, x minus 5 and x plus 3. That's my common denominator that I needed here. My numerator, I'm then going to simply distribute the 4 to each of these terms. So for our next step, we've got two binomial factors that make up the numerator of the first fraction. To multiply them together, we'll use FOIL. We'll multiply the first terms, the outer terms and inner terms, and add them together, which will have negative 2x minus 5x, giving us negative 7x. And the negative 5 times the negative 2 gives me a positive 10 for a final term. Plus, whatever I get when I take these two expressions and multiply them together. Well, this is simply distribution. 4 times x and 4 times 3 gives me 4x plus 12. Excuse me. All of these terms are over that common denominator that we wrote down before, which is x plus 3 times x minus 5. At this point, all we have left to do is to add any like terms that we have in our numerator. For instance, these negative 7x and 4x can be added together, and the 10 and the 12 can also be added together. That will give us x squared minus 3x plus 22, all over a common denominator of x plus 3 times x minus 5. If there was a way to factor the numerator so that I could then cancel a common factor that I see from the denominator, I would do so, but I don't believe that there's any factors of 22 that can be somehow put together to equal negative 3 as a sum. So therefore, we're going to go ahead and leave this as our final answer.